Hey, John here. Let's look and see what it takes to print stuff out onto the standard output in a C++ program. What do we got here? I got an element, an array of 100 elements. Okay, I fill it in with something that's recognizable. Now, for test data, I like to be able to know what the heck I'm looking at when I'm printing out elements of an array. Did I print the right one out? Don't just fill this with garbage and look at numbers all over the place. So what I do is I fill it in with a recognizable pattern. I set the value of each element of the array to its index times 10. Don't just set it to the index, because then you won't know whether if you wrote your print routine down here and you printed out the index rather than the value, you couldn't tell the difference. Make everything unique and everything obviously recognizable as to what it is when you're creating test data. That's the way I like to do it. So what are we doing? We're going to fill in every element of this array with its index number times 10, okay? What's up with all this crap over here? Okay, well, this is an expression that will run this loop iterator I from 0 up to the number of elements in the array minus 1, okay? So what this really is 100. If I put 100 here, this entire expression right here will equal 100. This allows me to change this size without having to go around in my code and change all the dependent sizes. It also allows me to do this without defining a macro that says the array size shall be 100 and then using that macro everywhere, okay? You could argue either way. I just wanted you to see this particular technique. I use it from time to time. It can be useful. This only works, of course, if you have arrays. So let's see how it works. Well, what does sizeof do? Sizeof something. This is a compiler time operation that takes place. And what this does is it says, tell me the number of bytes that this variable here consumes in memory, wherever it might be stored. And it turns out that the number of bytes that an array consumes is equal to the number of bytes each element consumes in that array times the total number of elements, right? So if this is the total size of all the bytes in the entire array divided by however many bytes one single element consumes, then you do this division and you end up with the total number of elements in that array, okay? So this goes from 0 to 1 less than 100. So it'll go from 0 to 99 inclusively. At the end of each loop, I add 1 to it. So a sub I equals I times 10. This is how I fill it up with recognizable values. I do the exact same thing, and I print it back out again. And I put a space after each one so I can see what the heck I'm doing. Let's go ahead and compile that. And, hard to type and talk at the same time. Okay, so let's run the program. Oops. Got to give it the path. Okay, so when I run the program, I can see it starts from 0, 10, 20, 30. These are obviously the values, and it goes up to 990. 0 through 99 as the index is exactly 100 items. And because I didn't put a carriage return at the end of my printing, my prompt is off here in the middle of nowhere. That's annoying. Nobody wants to see that. So what do you do to fix that? Well, you can come down here and you can add an extra print. When I'm all done, print an end of line. Run it again. Now it prints out the 100 items, and it prints a carriage return after the last one, and we have our prompt. Okay, that's a little bit more palatable, but it ain't great. You know, if I really want to see these 100 items, why don't we print them in a tabular form with, so many per line so we can see what's going on, because it's really hard to know, did all 100 of them show up here? I don't know. Unless I want to sit here wasting my time counting all to make sure they're all there, that's a problem. If I print 10 per line, I can easily count there's 10 lines and 10 in each one, and it ends up being a nice rectangular form on the screen. So let's look at some other ideas here. So far, so good. Let's add this. This might seem like a pretty reasonable way to take care of that problem. After the end of each one, print out, hey, if I'm a multiple of 10, throw in an extra carriage return. Let's see how that works. Okay, it's already compiled. Well, it's rectangular, but we only have one item on the first row. Then it looks like we have 10 items on each row after that. And then we have an extra carriage return at the end. I mean, we're close, but this is, no, this isn't good enough. Especially with that extra weird thing at the top. Well, what causes that extra weird thing at the top? Well, it's because I mod 10 being 0. This happens whenever I is a multiple of 10. That's what this expression means. Remember, the modulus division operation says take I divided by 10, throw away the quotient, and then keep the remainder. So this is the remainder after a division. So when I is 0, 0 divided by 10 is 0, and therefore this is true. 1 divided by 10 is 0, remainder 1. So this I mod 10 at that time is 1. Is 1 equals 0? No. So this will actually print out a carriage return after every 10th element. Unfortunately, the first index is also a multiple of 10, so we can get rid of that by adding I not equal to 0 here, and I have a divisible by 10 value. Then I want to print a carriage return. All right? That might help. So far, so good. Now we have 0 through 100. How many do we have here? This is too many, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 11 now. And then what's on this row? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, well, we really did is we smushed that first 0 on a line by itself into the first line and ended up with too many. So that doesn't quite work out right. Now what do we need to do? Well, it turns out if there's too many, we don't want this to come back to a 0. What we want it to do is end at number 9. Okay? Now it turns out we can also get rid of this at that point, but let's go ahead and compile this and see what happens. By asking if the modulus division of I mod 10 is 9 rather than 0, what happens is after it just finishes the 9th index, which remember is the 10th element in the array because we start counting at 0, now it's working correctly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? And you know this is 10 because it starts at 100 and goes up to 190 and so on. And this guy down here on his own works out because we have 101 total items in our array. Let's see if it works with 100 because that's our edge case, right? Because we're doing lines of 10 at a time. Oops. Well, that's weird because we have an extra blank line down here. That just shows that somebody didn't think about what they were doing very well. So what's wrong with that? Why is that true? Well, it turns out you can't just blindly throw an extra carriage return down here because if you just happen to end up with the very last element that you print out in this loop in here, it happens to include a carriage return after it, then you'll end up with 2. So you only want to do the one down here if you're supposed to, right? If you didn't do one in here. So how do we figure that out? Well, it turns out we can essentially ask if it ends. What we want to do is basically re-ask this question and say if this is not true. We kind of want to do this, right? If that's not true, then do this. But we can't do that because the scope of this I variable is only in this for loop. I doesn't exist down here. All right? A couple ways to do that. We can declare I up here so that when the loop ends, I still has its value, but it won't have the value that it had in the last time it executed this loop because it will then have been added. It would have been incremented. So I down here will be 1 more than it was inside the loop, so you really can't reuse this expression anyway. So this is just a disaster. I don't want to deal with that. You could probably figure out how to do it that way, but that's kind of a pain in the butt. Let's think about this for a second. when do we want to print this? When do we really want to print it? Well, if the size of the array has an even multiple of 10 elements in it, then we know we will have done that up there, because that's what this thing does. After the 10th one, it'll do one in here. But if the array does not have a multiple of 10 elements in it, it will not have done that in the last one. So why don't we just simply ask, are there a multiple of 10 elements in this array? And we can just do that like this. Okay? Or more accurately, does it not have a multiple of 10 elements? Because only when there is a multiple of 10 elements will it have done this the last time it went through the loop. So if it is not a multiple of 10, right? If the number of elements mod 10 has any remainder that's not 0, then we know that last line had a non-number of 10 elements. It would not have done this. Then and only then do we want to print our extra line. So let's go ahead and see if that works. All right, it got rid of it. Did it do the right thing? We're printing exactly 100 elements. There's 10 per line, 0 through 9, 10 through 19, and so on. That looks good. Let's make sure it still works in the other cases. You'd be a fool not to test the other ones. Or retest them, I should say. Yeah, I said put 99 elements in there. That means it should go from 0 to 98, and they're all times 10, so there's the extra trailing 0 on there. That works. What about 101? That works as well. So this takes care of all cases. We now have a nice rectangular printout. Well, almost. So this isn't too bad. We're getting 10 elements per line. It's almost a rectangular shape on the screen. That would depend on formatting and spacing. And we'll talk about that in a minute, but, this is kind of screwy. You got the when I is not 0 and I mod 10 is 9 and this thing is not 0 down here. Well, this really isn't too bad, but there's another way to do this. And as you'll see, it might actually be more beneficial depending on other things that are going on in your code. Let's look at another way to do this. In other words, rather than putting the choice to print the extra carriage return at the bottom of the loop, let's put the choice at the top of the loop. All right, so at first glance, if we just move this expression up to the top of the loop instead of the bottom, let's see what happens. Okay, well, we can see it didn't end right because we got a number followed by my Unix prompt. It didn't print the right number of elements on the first line. There's only 9 here, right? 0, 1, 2, 3, 4, 5, 6, 7, 8. It's only 9. Then down here, the 9th element comes out. At least there's 10 down here. But the first time through, I got the wrong number of items. Well, okay. So we broke it. What do we need to do here? Well, because we're printing the carriage return before we print the value of the element out, we don't want to do it mod 9. We want to do it back to mod 0, okay? We only want to do this on the 10s, not the 9s, right? So the 9s were needed because you'd print it first. Then you would do the carriage return. But if you're going to do the carriage return and then print it, you got to go back to the 10s, okay? So let's see what we got. Now, did that work? Yes, we have a multiple of 10 here. 10, 10, 10, 10, 10. Comes out even, and it ends in a screwy way. But okay, but at least it starts right. So if you want, my point is, if you want to put the condition at the top of your loop, you can. It's critically important now to make sure you have the I not equal to 0. You don't want to print a blank line in the very first time through your loop, because then it'll put a blank on top of all your output. Okay, so that works, but now this down here is broken. When do you want to print the line down here? Well, this is one of the benefits of this style, okay? If you print the carriage return before you print the value in this loop here, we know that whenever this loop ends, it will have always just printed an item, and there is never going to be a carriage return after it. So our first idea might be to do this. When that loop ends, I always need a carriage return. That's definitely easier. Let's run that. Works perfectly, all right? How about when there's only 99? Of course, it's going to work perfectly every time because we always print the carriage return, and as it is written, it always needs one. So that worked. Let's go back to 101. That works. Okay, that's great. What if we only print out one thing? That works. What if we print out 0 things? Now we got a problem. Yes, you can have an array of 0 elements. It prints out nothing, and then it prints a blank line. Well, this is kind of a weird special case I have to handle in this specific example. However, if this was a subroutine that was supposed to print something, a table or whatever, it could be called, theoretically, with a 0-element table, and you wouldn't want it to do anything screwy. So what do we need to do here? Well, we do have to handle this special case, and the case is, is there anything to print at all? Is that value there not 0? If this is greater than 0, then and only then do you want to print the extra carriage return at the end of the last line. This should take care of that problem. Prog 3, I'm using the shell history, so it might be hard to see. So when I do prog 3, it had a 0-element table, and it did not print any extra carriage return. This is perfectly clean output. Now what if I print one item? It prints the one item and the carriage return. My prompt comes back correctly. What if I print, whatever, my 99 items? Yes, right? Because 99 goes from 0 to 98 times 10 because of the way I filled the data in. That's perfect. What about my 100 here? That should work as well. That's exact. And we have a carriage return. Okay, that looks good. What about our 101 case? These are, the corner cases, we call these, or the edge cases, or whatever you want to call them. You need to test all these to make sure they always work and that it works perfectly every single time. And as we can see, this does work every single time. So this one is equivalent to what we started with. Now, it turns out, in my opinion, this is a little easier to understand. You simply are asking, are there any elements that are in the array at all? If so, print the carriage return. This thing here makes more sense, in my opinion, because I'm really dealing with I mod 10 equals 0. That's, mentally, to me, that kind of makes sense. I can look at this and not be kind of like, oh, is that 9 really makes sense, like we saw in the prior example. I mod 10 is 0. I know this is a multiple of 10, so without looking at the output or running the program, I can know this prints a carriage return after every 10, whenever I is a multiple of 10. To me, that says 10 elements per line. This is a little more intuitive, in my opinion. Now, we'll also see this structure is also useful if you need to put a header and a trailer on every single line and stuff like that. So let's run with this idea. So let's start by not just printing out a carriage return after every 10th element and a carriage return at the end of all the elements, okay? Let's put a triple X here and a triple Y down here. This will make sure that we always understand when the end of the line is being printed by the loop versus this extra one down here. Let's run prog 4. All right, not too bad. We've got 10 elements here with a triple X. That makes sense because that was printed inside the loop before it printed the 100 here, and it got to the end of that line. And then you see this triple X there, which was printed before it did the 200, and then it runs through this line in the main loop ends, falls to the bottom. It determined there's more than 0 elements in the array, and it prints the YYY down here. Okay, so far so good. We just mark those out, and you can use these locations if you want to put a trailer on the end of every print line. Who knows? Maybe you're adding up the numbers and you want to print the sum each time at the end of each line. You could easily use these points in this code to print the sum instead of triple X or triple Y like this, all right? Now, yes, you'd have to do it twice, but you're either going to have a special case for the first row or a special case for the last row. This is just a problem you're going to have to deal with. All right, so what about a header on each line? Well, we can also ask similar kind of a question here. Are we at the beginning of each line? Well, it turns out being at the beginning of each line is the same thing as being at the end of every line, right? That's not a problem. So one way to ask if you're at the beginning of the line is this, right? Remember, we got if I is greater than 0 or non-zero and a multiple of 10 is when we want to print the trailer. Well, it turns out we want to print the header only when I is a multiple of 10. Now, this is true because we want to fire this if expression when I is 0, as well as when it's 10 and 20 and 30 and so on, all right? So to print a header, you just put whatever message you want to print in there in here, okay? So now, if we need to end a line, we can. If you need to start a line, you can. Now, you might think you want to do something like this and put the header before that. No, you don't, because if you want to print the end of the line, you certainly don't want to print a header followed by the end of the line followed by the element. No, this doesn't make sense at all. You need to do it this way. If you need to end the current line that you have been printing, you need to end it before you print the beginning of the line that follows, all right? So let's look at this header. It's going to print ix, which means to me index. I'm going to print the index variable out that the loop iterator is using, and then I put a colon and then a space, and then I'm going to put these values, all right? Let's try running this. All right, not bad. I now have a header. Index 0 is the index of the first element in this line, and it goes to here, and then there's a trailer. Now I've got index 10, which makes sense because there's 10 per line. So this is number 10 through 19. This is index number 20, which signifies the 20th through, in this case, 28 value of the index, right? So this is what? Printing out, it looks like 29 elements or something like that. Okay, so let's go back to our 100, which is an exact multiple of 10. Make sure we test, all of our test cases. Exactly 100 comes out perfectly. We have all the headers, we have all the trailers, we have the last trailer, as you can see, was printed at the outside the loop, which it always will be. And we don't have any extra headers for no data. It's perfectly rectangular, at least as far as data is concerned. We'd like to format this a little bit nicer, but that looks pretty good. And we know we're never going to have an extra index because the last thing we do in our loop is print a data item. So you don't have to have this screwy thing to pretend not to do it in case you're done, but you're in the loop one extra time, sort of like what's going on up here to get rid of the first time. You don't have any special logic to deal with the last time here because there is no last time. There's either something to print or not, okay? So this looks like it works out pretty nice. Okay, so I added this set W here, and I've done it down here as well. Remember, I included IO manipulators, okay? Inside this header file, it defines things like set the width, all right? Now, you'll see sometimes these manipulators will apply to whatever one formatted element that follows in this print expression here. And other times when you set a manipulator, it might stay set for all subsequent formats, okay? It turns out set W applies once and only once to whatever the next conversion is that it uses for formatting and printing something, okay? Now I've also added a set W down here. The commented outline is what we had before, and I added a set W here as well. So I'm going to print out everything with 4 characters for each one of the fields. Okay. So now I can read this more easily. These are all bunched up all over the place. If it turned out these numbers happen to be random between 0 and 1,000,000, they'd be all angled all over the place, right? So if you give them all a fixed width like this, you have a perfectly rectangular table, and you can see all these columns lining up and so on. Now, I still have these trailers marked like this, and the last one is scooched over to the left a little bit, but this is just to make sure that we remember why we have the ends of those lines, which code printed each one of these things, all right? The header looks good. They're all spaced out to consume these 4 character column widths, all right? Now, there's other manipulators you can use while we're in the neighborhood. Let's say, for whatever reason, I want all my values to be printed out with leading zeros, right? Instead of putting spaces, I want to put a 0 in front of each one of these elements as they come out, you know, for whatever reason. Now, if we run this... Well, that's interesting, because I told it to put leading zeros on these when I'm printing the values. I did not tell it to print zeros on the index, and I do have one index with spaces. The rest have leading zeros. We'll set the fill is one of those things that stays set once you've set it. So if I want to set it to 0 here, and I don't want leading zeros for whatever reason on my index, I need to put it back to space up here before I print my index values, all right? So now, if we run this program, we have space padded on the left of my indexes, and we got 0 padded values for the values in my grid. All right, so this is looking really nice. I have a nice rectangle. I got everything I want, almost. I do know, let's go ahead and change this. Maybe I got 103 items to print out. What if I want to know the value of the element in index number 52? Well, I come down here, I find my 50, that's easy to do, and because I've actually stored a variant of the index as its value, you can clearly see that that's the 52 item there, right? Element index 0, element 1, element 2, and so on. I go down to 50, there's 51, and 52. But if these values didn't happen to have the index number hiding in there, if I want to know where 77 was, and these were all just random numbers, I may have to count it out. There's a 71, 2, 3, 4, 5, 6, 7 in my head. Or I might know that it's going to be over on the right because it's closer to 80. I might look at counting the other way around. It's going to be 79, 78, and 77, all right? And if you put more items per line, this even gets more difficult. So let's do something to help us in that regard. Since there's 10 per line, what if we print the first 5, and then we put an extra space in here? So then in your head, and you want to know where 55 is, it'll be left of, or rather I should say right of, this extra space that you'd put in the middle, because there's 5 on the left, that's 50 through 54, and then over here would be 55 through 59, right? So how do you do that? All right, so what are we going to do in here? That's actually works a whole lot like putting a heading at the beginning of the line, doesn't it, right? Well, every 10th time we print something, we want to put a new heading on there, including the 0th time. So this basically, quite honestly, is nothing other than a heading, but you do it at a different time, all right? So let's say we want to say the fifth item right here, all right? And we want to just throw in, an extra space in there. You do it like that. And we have an extra space in here. But this kind of is weird. This also moved over on the left over there. There's an extra space in there. Maybe I don't want that. So if you think about it, mod 10, including the 0th time, is how we force this to print on the first time through. Well, we have the same kind of a problem here, a similar one with mod 5. We want it to be mod 5, but we don't want to do it when it's mod 10, all right? So what's going on here? Well, you got a couple of options. So because all mod 10s are also mod 5s, this is firing twice as often as it should. So you could say something like this. So I want all mod 5s that are not also mod 10s. Okay. That's perfect, right? It did not put an extra space over here, and it does keep the extra one in here, making it easy to find 66. That's right here, because you know this is number 65. This one's your 66. We got all the trailers and all that working beautifully. Okay, that's not too bad. And, you know, I happen to know the compiler's smart enough to optimize this away, but there's less code you can write if you just did this, right? Just FYI, you could have just as well done that, because you already asked if I mod 10 is 0 up here, print the header. Otherwise, if it's a mod 5 and not mod 10, you can print this space out down here, okay? Less code is usually better, but it may very well be that it could get harder to understand. So don't remove code unless it's a good idea, all right? So now we've got these groupings, okay? We've got headings, we've got trailings. This is a much more easy to read set of output. Now, of course, we have noisy trailers in here right now. If you remove these, it might literally be easier to read. There's also some other weird cosmetic problem here. See how I print the value of this variable followed by a space over here every time? Well, it turns out that extra space, when it is at the end of the line, combined with this space here, ends up printing 2 spaces between that last element and these trailers, does it not? Look what's happening over here. I got 2 spaces over there. What if I don't want that extra space on the right? Well, you can use similar kind of techniques that we've been doing here. One obvious way to do it would be to print the space first, or just set W to 5 right here, right? That would add more space literally on the left of that element whenever it prints it, okay? And it would get rid of the extra space on the right. So if I run this now, it should look formatted exactly the same way, but these now should jump over closer to this, because remember the trailer I printed had a space and a triple X, and the one down here is a space and a triple Y. So let's go run this one. Whoops. That didn't quite work the way I thought it was, and it's because I wasn't thinking, because set fill 0 is set. All right, if you really want a space, you can do it like this. Put this back on 4. You could use this technique if you had a fill that was a space in here. Okay, now you can see it does what we intended, although now we have an extra space on the left, which does make a certain amount of sense if you think about it. If you always print a space before you print your item, you're going to end up with the extra one on the left instead of the extra one on the right. Now, there's a couple of ways to deal with this too, right? Well, if you always want a space after the index, you can take the space out of here, right? If I wanted to, that would remove one of those 2 spaces and get you back down to only 1 between the index and this element here. But what if you actually really did want 0 over there? Then you'd have to ask some other questions like, this imod 5 thing over here. Well, what I would do is I would experiment around. Maybe you start with something like this and say, well, if imod 10 is not 0, print a space. Off the top of my head, something like this might work. Never caught an audible in the middle of recording a video. This will probably go against me. So what does that really mean? If imod 10 is equal to 0, I know I'm at the point in time when I will have just done this index up here. I could actually change this and mix it all into this one else down here, but let's just leave it the way it is. If imod 10 is not 0, I know I'm printing all of the items to the right of the index, but I am not in the case where I just printed the index. So I'm pretty sure this one will come out right. But this is what we need to test all these things, right? And yes, it did. It came out just perfect because, like I said, we're trying to get rid of the extra space here, and we also didn't want that extra space over here, and the one that's printed now is part of the trailer, in fact. We also still have the one in the middle, so this is how you would take care of that problem, okay? So this is kind of ways I use to format the output of my data when I'm trying to create, you know, a dump of something, even if it's, you know, the desired output or just debugging output. You need to be able to see what you're doing and make sure that when you read your debugging output, you're always 100% certain that you're reading the output the way it should be read. All right, so I hope this helps. I'll see you next time. Bye-bye.